Okay. So yeah. So basically, we know that it is half times q square over c. You can use any formula that you need, but because we need total energy, so we need to see what will be the energy stored in A plus the energy stored in B, which means that this is going to be half. The charge on A was 360 microcoulombs whole square divided by 60 microfarads, plus the other one was half times 240 microcoulombs whole square divided by 40 microfarad. So you should be getting somewhat like 1800 micro joules then, because one micro is going to be left, right? So the micro and micro, there are two micros because of the square, they will cancel out, so only one micro is going to be left. Please check if you get this same answer. All right. If everybody understands this, should I go forward now?
Yes.
Okay. Now, today the main basically concept that we're gonna discuss is it's called the safe operating voltage. Now, safe operating voltage is basically if you buy a capacitor, right, from the market, on that capacitor they will give you some ratings of that capacitor. So capacitor basically looks like this. I showed you this before as well. And when you do that, it's gonna basically show you okay like that. So on a label, let's suppose it's written 1000 microfarad and 16 volts max. Now basically what this means is that, talking about this capacitor only, so this capacitor can have a peak voltage of 16 volts. What it means is that it will explode if greater voltage is supplied. So this is the maximum voltage that we can supply to it. So we got to design the circuits according to this maximum voltage, right? So just remember that every capacitor has a particular safe operating voltage. So please write this down and then we're gonna go forward. Okay. Yes, Samir, you did, and it was correct. I'm very impressed. And those who are not working, I'm very, angry at you people. This is extremely poor behavior, by the way. Okay, please write this down, and then I'll tell you how we can work it out. All right. So, for example, let's see. You have one capacitor like this, another capacitor like that. Uh-oh. Okay. You have basically given with something like this, right? So, it's so bad. Doesn't understand what I'm saying to him. Okay, so this capacitor is 60 microfarad. This capacitor is 30 microfarad. So they said that both capacitors have an 8.0 volts safe operating voltage. So the question is, what is the maximum voltage that we can provide in order for these capacitors to work, right? So let's write the question. What is the minimum or maximum? That's right, maximum voltage V max that can be supplied so device does not blow. So this is what the question says. All right. Now there are certain steps you got to take. All right. The first step that you always remember. So that's right. Step one. When looking at it, you'll see you need to consider the smallest capacitor first. Okay. And the smallest capacitor, smallest will get the largest possible voltage. In this case, it is 8.0 volts because that is the maximum voltage at which it is safe to operate. Is it clear, everyone?
Yes.
Good. Step two would be that in series, charge remains same. So 60 microfarad will also get the same charge as 30. Because first you're going to always look at the small one. Is it clear, everyone?
Yes.
Now, first of all, we're going to follow step one and find the charge on the capacitor 30. So charge would be equal to, let's call this A, let's call this B for reference. All right, so QB, which is the smaller one right now, is equal to C times V. The capacitance is 30 microfarad and the maximum operating voltage of these were 8. So we're going to apply the full voltage here because we want to find the maximum. So the charge that will be developed on the smaller one is going to be 240. Now, if this gets 240 microcoulombs, then this will also get the same amount of charge. Do you guys get it?
Yes.
So then we can find the voltage. So we have the voltage across this one as 8 and 8 volts. And now we're finding voltage at A. So voltage A will be Q upon C. The capacitor will have the same charge as the smallest capacitor in the circuit. And then you got to divide it by 60. This will give you actually 4 volts. So if you apply 8, the maximum voltage that can be applied to 60 is just 4, which means, hence, V max cannot go beyond 8 for B, 4 for A, so it cannot go beyond 12 volts, and this is basically our maximum operating voltage. If you guys have any questions, please let me know. Now, I just want to tell you two important points. It would be best if you write note here, and note should say number one, smaller value capacitor gets the gets greater voltage in series. All right, so remember that, because the voltage splits in inverse ratio of capacitance. You got to remember that. And we know this because you see Q is equal to CV and C is equal to Q upon V. So these two are inversely proportional. That's fine. Understood? Because every capacitor will have in series the same charge. On the other hand, if it is asked from you that in parallel, smaller value capacitor gets lesser charge, because in parallel the charge splits in direct ratio of capacitance. And from the formula it is evident the voltage is constant, like for each branch. So the smaller the capacitance is, the smaller the charge is going to be, because they are like directly proportional. Understood?
Yes.
All right, please write this down. These are very important. They can ask you this at different occasions, and we don't want to miss that. Good. So, okay, I got to go to the next page. So please let me know when you're done. Yes, Dania, you have a question?
No, sir. I was just sorry.
Okay, you were raising hands, so I thought maybe you have a question. Anyway, not a big deal. Now, what do you guys say? Should I go forward now?
Yes.
Now, going to the next, and that would be basically how would we design a proper circuit. Now, in some questions, they're going to ask you. So I'm going to do it. Question that says, a number of capacitors of value 48 microfarad 6 volts. Now it means that 48 is the capacitance, 6 volt are the maximum voltage that you can put them against. All right, are available in the lab. Now they say number one, design a total capacitance of 48 microfarads circuit suitable to use with maximum voltage of 12 volts, battery with only 4 capacitors, right? So we got to use that. Do you guys get it?
Yes.
Now, how would we do this type of questions? Let me just tell you. First of all, think about it this way. You can't go beyond 12 volts, and you can't actually go beyond 6 volts as well, because the issue is that if you go beyond 6 volts, it's going to blow that capacitor. So if I put one capacitor like this and like that, so always start from a series one. This will help you analyze whether you're going in the right direction or not, right? So I'm drawing this capacitors. Now in this one, I can see that if I use 48 microfarad and 48 microfarad, I got to use 4 of them, right? So in series, the capacitance is halved. Like in this section, the total capacitance will be 1 upon 48 plus 1 upon 48. It's going to give me a total of 24 microfarad. Do you guys get it? But the issue is that if this is 6 volts, this is also 6 volt, I can still put a 12 volt battery, that is correct, but I'm not getting the total capacitance of 48. So what I'm going to do is, I'm going to put 2 more capacitors in series, but these two will be parallel with the first 2 capacitors that I put in my circuit. As you can see, this is 48 now, this is also 48, but then these are also getting 6 volts and 6 volts. But then when I connect this to a battery, you guys can see that the total voltage will be 12 volts, because 6 will go on one and the 6 will go on other, and each branch will have 12. Is it clear? In this section too, the capacitance total will be 24 microfarad. But in series, what happens is that in it's basically added like we take inverse, but in parallel, what we do is we can simply add them. So in this section, we have 24. In this section, we have 24. So basically, I can say that the total capacitance now would be 24 microfarad plus 24 microfarad. So that's gonna give us 48 microfarad. Do you guys get it? So this is the right circuit.
Yes.
You're not supposed to go beyond 6 volts in each. You can go below that, but not beyond that. Because if you go beyond that, the capacitor will stop functioning. Is it clear? Abia, Abu Bakr, Aisha, Dania, everything is clear?
Yes.
And Afan, Huda, what about
Yes,
Javeria, Khadija's, Ryan, Samir, Zainab? Everything is clear? Should I go forward?
yes, sir.
Okay.
Yes.
Yes, sir.
Now, I'm going to give you a question. Let's see if you guys can do this. It says design a circuit of total capacitance of 72 microfarad suitable for Vmax of 6 volts. Like we have a maximum voltage of 6 right now. We can't go beyond that. But also we have the same capacitors, right? Each capacitor is rated 48 microfarad and 6 volts too. Use only 3 capacitors or less. So that's what you're going to do. Can you please try and do this? Let's see if you can manage this. You have 2 minutes.
Done, sir.
Okay. Can you describe your circuit?
Two of the capacitors are connected in series,
Okay.
and then one of the capacitors in series has another capacitor connected with it in parallel.
One of them, like you're saying, two capacitors in series, like this, and then another one like this. This is what
Yes.
you.
Yes.
This will give you 48 plus 48, and that is
It won't be. It
48.
won't. It won't be 24.
No, because in parallel they add up. You have to solve the inner circuit first. So 1 over 96 plus 1 over 48, 1 upon answer. No, that is going to give you 32, not 72. That's wrong. Anybody else has a different answer? You have to check, huh?
Sir, what if like there are two capacitors that are in series and the other one is parallel to both those capacitors that are in series?
Like this?
Like this. Yes.
Yeah, that is the correct one. The reason why this is the correct one is, check this out, kids. You got two capacitors, those are in series. So always try to make like the series first. And now you will see that this will be 48. This will be 48. So the total capacitance would be 24 microfarad. You guys agree? That would be capacitance series, right? You can check as well because we have done it on the top, so that's why I'm not doing it again. If you connect, now what you need is you need to add 48 to get to 72. So if I do that, then basically I will have 48 here as well. So now because this is in parallel, so the total capacitance then will be 24 for the series one, and parallel just adds up. So that's going to be 72. Do you get it, Irfan?
Yes, sir. And how will the voltages be distributed?
Now let's see. So then the maximum voltage that I can use is 6, right? So it means that 6, this will get the whole 6. This will get 3. Sorry. This will get 3 volts. This will also get 3 volts because you cannot go beyond 6. You can stay within that limit. Understood? So that's good.
All
Do you
right.
understand this? Yeah. All right. Who did not understand that? Aisha, everything's clear. Samir and Abu Bakr,
Yes, sir.
both Khadijas.
समझ आ गई
Very good. Very good. Now let's check. What if they have given you the voltages and the capacitances, and we need to find the maximum voltage that can be applied. Okay, so let's try that now. So you guys can draw this piece quickly, and then I'm going to go forward. This chapter is quite, like all calculations, very little to write. Okay, now going to the next one. Okay, so now it says in part 3 of this question, calculate the maximum voltage Vmax in the following circuits. All right. So the first circuit they have given to you, that looks like there are two here, and this. Okay, we got to find V max. These are the same capacitors: 48 microfarad, 6 volts, 48 microfarad, 6 volts. Right. Now, because in series we know that the voltage is distributed like with respect to capacitance. So if I apply 6 volts to the minimum capacitance, then other one is the same. So I can also apply the same to the other one, 6 volts. So total will be 6 plus 6, 12 volts. So I can actually apply 12 volts here and it will be fine. Do you guys get it?
Yes.
Now let's look at another one. So this is A. Now let's look at B. In part B, they have shown two capacitors which are in parallel. The same capacitors, 48 microfarad, 6 volts, 48 microfarad, 6 volts, and now they're connected to the battery, which we want to see what is the maximum voltage battery that we can use here. Can somebody make a wild guess here? What would be the maximum voltage that we
6.
can do? Why 6?
Because potential difference remains same in parallel combinations.
That's right. You can maximum go for 6 volts battery, because if you go beyond 6 volts, then because its operating voltage is 6, it is gonna blow. Do you guys get it? Because in parallel, voltage in each branch remains same. Do you understand this?
Yes.
Yes.
Now I'm going to do one question, a big question, and then I'm going to give you one that you should be doing, and let's see how many people can actually attempt that, because these ones were so easy. Let's look at part C. So now the real question comes up here. So we have one capacitor, then we got 4 capacitors. Oh my god, I have to make so many capacitors. Oh my god, already tiring, so tiring. Okay, wait. Okay, so I have all these capacitors. Set of 4. They're all in parallel. Then it's further connected to 2 more. Like this. And then 1 more. Big circuit. Huh? Okay. And then it is connected to the battery that we need to find the voltage of. Chal, that's so bad. Okay. Done. So this is our circuit. So all of these are rated 48 microfarad and 6 volts. Is it clear, everyone?
Yes.
Now I'll teach you how to solve these big circuits. Very easy though. So there are two methods we can do. So first of all, you people, we are gonna name these that as capacitance 1 or combination 1. This is combination 2. This is combination 3. And this is 4. Okay, you people? And then I'm going to check what is the capacitance in each of these. In combination 1, we got 48 microfarads because just one capacitor. These are 4 in parallel. So in parallel, they just add up. So 4 into 48 is basically, the capacitance here is 192 microfarads. Understood?
Yes.
In the second one, it is 48 into 2, which is 96 microfarad. And this is just one. So in this one, it is 48 microfarads. So this is the total capacitance in each section. Let's also give them some voltage. So this one has voltage 1. This one has voltage 2. This one voltage 3. This one voltage 4. So I've given them voltages now. Now, when I started doing this today, we basically learned a very important lesson, and that was that the first step you always got to do is that you need to consider the smallest capacitor first, right? And then we have to find the charge that is on that. And then every other combination shares the same charge, which means right now, in my question, the smallest capacitor is this one. Do you guys get it? So I can say Q equals to CV. I'm talking about Q1, C1, this one. So it is 48 microfarad, and I'm going to apply the maximum possible voltage that I can give, which is 6 volts. So I'm going to put 6 here. I'm going to end up with having 288 microcoulombs. If the smallest gets 288 microcoulombs, which means this hole will also get the same, and this one will also get the same, and this one will also get the same. Is it clear, everyone?
Yes.
This is the first key that you got to do. Now, the next step, so I'm just writing here, this is method 1. Okay, the people who like this method, they can, then I'm going to teach you another one as well. So now, if I want to find the voltage for combination 1, so voltage 1 will be Q over C1. The charge on 1 is 288 microcoulombs. I'm just doing it again just to explain how I get these answers, but it's a redundant step. You don't have to do it again. For voltage 2, the charge was 288 microcoulombs divided by 192 microfarad. That's going to give you, I think, 1.5. Is it clear? Now V3 is going to be the same charge, but now the capacitance of that combination is 96. I think it is half, so it has to be 3 volts. And V4 is the same as the first one, so it's going to get the same voltage. But you can still check if you want to. That would be 6 volts. Do you guys get it? Now you're going to sum it up. So the maximum voltage is going to be 6 plus 1.5 plus 3 plus 6, and it's going to give you 16.5 volts. So this is the maximum voltage I can apply on the battery so that every other capacitor works fine. Understood, everyone?
Yes.
Can't go beyond that. Anyway, now you can write this down, and I'm going to go to the next method.
Copied it, sir.
Now, method 2. Method 2 is a different method. It's basically completely mathematical ratios. So I'm going to teach you this. If you want to follow this, it's okay. If you don't want to follow this, you don't like it, nobody's forcing you to do that. So sit back, relax, and see what I'm doing. So in this method, what you're going to do is, this is convenient method for large circuits. First of all, you're going to find the ratios of capacitances. Okay, so this is the first step. Let me just try to use a different color. So we have C1, ratio C2, ratio C3, ratio C4, right? C1 is of 48, C2 is 192, C3 is 96, and C4 is also 48. Get it? Then what you're going to do is you're going to find the smallest number amongst them and divide each ratio with this. So this will be 1, this will be 4, this will be 2, this will be 1. Get it?
Yes.
In the next step, you're going to basically do ratios of voltages. Now, as we know, that voltage is inversely proportional to capacitance. So how do we apply inverse proportions? Let me just write it here with a different color. What color do I use? Chalo, green is fine. V1 ratio V2 ratio V3 ratio V4. So what you're going to do is you're going to pick the largest ratio and write that ratio in underneath each of the voltages. Done. When you do that, then divide the individual ratios onto it. Like this one had 1. Oh my god. This one had 1, so I'm going to divide 1 underneath. This one had 4, I'm going to divide 4. This one had 2, I'm going to divide 2. And this one has 4, I'm going to divide 1. Get it? So the first step was that I picked the largest ratio, put it underneath each of the voltages, and divided it with the number that was there, like 4 over 1, 4 over 4, 4 over 2, and 1. So I'm basically dividing this here, this here, this here, this here. Get it?
Yes.
So what I'm going to get is, I'm basically going to get this as 4 ratio 1 ratio 2 ratio 4. This is basically called the flipping of inverse ratios. All right, those people who have good maths, they can actually follow this. So all right, now remember, what did we do? On the first one, we applied the maximum voltage. It was 6. So I'm going to put 6 here. So if this is this, what will be x? So I'm going to cross multiply. You see, 4x equals to 6. So then 6 over 4 is 1.5. Do you get it?
Sir, can you repeat?
I'm going to cross multiply to find this ratio, like that. You see? So it will be 4x equals to 6. So x will be 6 over 4, which is 1.5. So I can write 1.5. Understood?
Okay. Yes.
Like that. If 4 is to 6, then 2 is to what? If 4 is to 6, 3, right? If 4 is to 6, then 4 is to 6 as well. Understood?
Yes.
Now add all of these. So V max will be 6 plus 1.5 plus 3 plus 6. That's going to give you 16.5 volts as well. So whether you like the first one or you like the second one, both are allowed. Both can give you the right answers. It's really up to you what you want to do. Is it clear?
Yes.
The ratio method is a bit faster, but then it's only for those people who dislike equations and like math. Well, that's an irony. Okay. Then I'm going to give you guys a question now that you can solve. You can have, is everybody done writing this?
Yes.
Okay, so let's go to the next. So part D, and that is for you people to solve.
Right now as homework.
It's very easy. You can do it right now in 2 minutes actually. This is the typical question that you're gonna get in the paper. I've basically done the most difficult one so that you don't feel like you don't know what to do. But this one is easy. I believe so. So basically it's a combination like this. It's connected to a battery. You got to find the voltage of that. Like that. This is again the same 48, 48, 48. Rated 6 volts, 6 volts, 6 volts. So you got to find Vmax. Can you please quickly do this? If you're following the yeah.
Max निकालना है.
Yes, that's correct. I think those who will follow ratio method will have can be done in 30 seconds.
In parallel, capacitance add up, right?
Yes, that's correct. Okay.
I'm getting 18 volts.
18 volts,
So मेरा 9 आया है.
9 volts. Okay, anybody else who got the answer to this? 18 volts is the incorrect answer. 9 volts is the correct answer.
First of all, assuming that the single capacitor is C1 and the two capacitors in parallel are C2. C1 is
Yeah.
equal to 48 and C2 is equal to 96.
Yes, that is correct.
I took the ratio C1 ratio C2. I'm getting a ratio of 1:2.
Correct.
Then if I take the appropriate V1 ratio V2, I'm getting 1:2. I mean 2:1.
2:1, that's correct.
That's where I went wrong.
Yeah, 2:1 because you need to flip, right? That's fine. Anyone who has got the answer? Yes, Zainab.
Is it 9?
So I got 9 volts.
Yes, that is correct. Very good, my people. Whether you do like other CV, the smallest capacitance here is 48. The largest capacitor is 96 microfarads. So this is going to be 48 according to that, you got to multiply the maximum operating voltage. So it should give you 288 microcoulombs. Then for V1, you can do Q1 over C1. So that's going to be 288 microcoulombs over 48. It will give you 6 volts. And then for V2, it's going to be Q2 over C2. Q is the same, microcoulombs divided by 48 microfarads. That's going to give you, sorry, that's 96, not that. So that's going to give you 3 volts. And ultimately, you're going to get V max as 9 volts, right? If you followed the ratio method, then you would have done C1 ratio C2. It's basically 48 ratio 96. This gives you 1 ratio 2. Then you have to do V1 ratio V2. You got to do this largest ratio right here and then divide by each ratios here. So it's going to be 2 ratio 1. And then what you're going to do is, because you applied 6 volts on this, so if 2 is to 6, then 1 is to 3. The total is going to be, V max is going to be 6 plus 3, 9 volts. Is it clear, everyone? Okay then. So we are done here. If you still have any questions, please let me know. Otherwise, feel free to go. We will see each other tomorrow then. Have a nice day. Bye.
Okay, Allah Hafiz.
Bye, sir.